Hello everyone, welcome to YouTube classes of Unique World Education UAE. So my name is Muhammad Sabid, here I am working as mathematics faculty. So today we are going to discuss few important questions from 11th grade mathematics chapter complex numbers and quadratic equation. We are not discussing quadratic equation right now, we are discussing few important JEE Mains previous year question from the topic complex numbers. Okay, so let's discuss the questions one by one. Okay. So the chapter we are going to discuss is nothing but complex numbers. Okay, I hope you know the basics of complex numbers. In all the videos we are covering the topic, covering the chapters and covering the question that only applying the basics only. Okay, only applying the basic concepts of that particular chapter. Okay, so let's discuss some questions from the complex numbers chapter. Okay. So it's a JEE Mains previous year question. All questions are JEE Mains PYQs. And okay, so let's start solving this one. Let A equal to theta belongs to 0 to 2 pi. It's a given in the set builder form. 1 plus 2i sin theta divided by 1 minus I sin theta is a purely imaginary complex number. Okay, then sum of the elements in A. So as you know, if a complex number is purely imaginary, what does it mean? If a complex number is purely imaginary, then we can say that the real part of that complex number will be equal to 0, right? So if a complex number is purely imaginary, we know the real part of that complex number z, that will be equal to 0. So they are mentioning in this question the complex numbers given in the particular interval is purely imaginary. But we know a complex number you have to write in the standard form. So what is the standard form of a complex number? It will be either in a plus ib form or some x plus iy form. Okay, if you are writing a complex number in a plus ib form, if you are writing a complex number in a plus ib form, a is called, as we know, a is called real part of this complex number and b is called imaginary part of this complex number, right? So the first initial task is you have to write this complex number 1 plus 2i sin theta divided by 1 minus I sin theta in the a plus ib form. Okay, so how to write? So let me start solving this by taking this complex number as z. Okay, so z, it is given that z equal to given that 1 plus 2i sin theta, 1 plus 2i sin theta divided by 1 minus I sin theta. This is the complex number is given. Now I am just trying to convert this into a plus ib form. So as you know, if a complex number is given in this format, we will convert into standard form by multiplying numerator and denominator with what? Conjugate of the denominator. So conjugate means just change the sign of the denominator. You studied rationalizing factor in small classes, same concept. Okay. So 1 plus 1 minus I sin theta is the denominator complex number. We have to multiply this with the conjugate of the denominator. So conjugate means just change the sign of the imaginary part. So this will become 1 plus I sin theta. So same way you have to multiply the complex number with the numerator as well. Okay. So numerator also we have to multiply with 1 plus I times sin theta. Alright. Now just if I am simplifying, what will happen? Z equal to, if you are multiplying the numerator bracket, it will become 1 plus 1 into I sin theta, that is I sin theta, plus 2I sin theta into 1, that's fine, 2I sin theta, plus 2i sin theta into I sin theta, we will get 2i square sin theta into sin theta, we will get sin square theta, whole divided by, so this is the numerator portion, whole divided by, in denominator we are having in the form, if you want you can multiply the bracket, but if you are observing denominator very carefully, you can understand one thing. Denominator is in the form of a plus ib into a minus ib, or a plus b into a minus b, if you want you can take. Okay, so a plus b into a minus b, a minus b, a plus b, it's a square minus b square. So this will become 1 square minus I sin theta the whole square, right? I sin theta the whole square, a plus b into a minus b, a square minus b square. Now just simplify this expression. So z will be equal to 1 plus I sin theta plus 2i sin theta. I can write 3i sin theta. 3i sin theta. Now 2i square sin square theta. So powers of I we are very familiar, right? I power 0 is 1. I raised to 1 is I square is minus 1, I cube is minus I, 1 I minus 1 minus I. So I square value is minus 1, so 2 into minus 1, so it will become, I can write minus 2 sine square theta divided by same way here 1 square 1 is coming, I square is minus 1 will come, so minus of minus this will become plus, so 1 plus sine square theta will come, right, 1 plus sine square theta. So basically you are getting complex number 1 plus 3i sin theta minus 2 sine square theta divided by 1 plus sine square theta. So you have to write in standardized form. So how I can write in a plus ib form, you know. First I am just writing the real part. So real part I can write 1 minus 2 sine square theta. Okay, 1 minus 2 sine square theta, 1 minus 2 sine square theta divided by this denominator is common for both, right. So 1 plus sine square theta plus, so this will be your a. Okay, this term is independent of the imaginary component, right. So this will be your real component, there is no I term in this. So 1 minus 2 sine square theta divided by 1 plus sine square theta plus 3 sine theta, 3 sine theta I, or I sine 3 theta divided by 1 plus sine square theta. So now if you are checking this thing, it will be in the form of a plus ib. It is in the form of a plus ib. So if a complex number is in the form of a plus ib, clearly in the question it is given that this complex number is purely imaginary. So purely imaginary means, as I told in the initial stage, the real part of this component, that is a component, will become 0. So if it's purely imaginary, I can write here 1 minus 2 sine square theta divided by 1 plus sine square theta, 1 plus sine square theta, this will become equal to 0, right. So 1 minus 2 sine square theta divided by 1 plus sine square theta equal to 0. What does it mean? So 1 plus sine square theta, move transposing, it will become 0 multiplied, that's 0 itself. So from here I can write 1 minus 2 sine square theta, that will be equal to 0, right. That means 2 sine square theta equal to 1. 2 sine square theta is 1, or sine square theta will be equal to 1 by 2. That means sine theta will be equal to what? Sine theta will be equal to plus or minus 1 divided by root 2. So if sine theta is plus or minus 1 divided by root 2, now we have to check the interval. Theta belongs to 0 to 2 pi. If theta belongs to 0 to 2 pi, theta value, sine theta is 1 by root 2. That means what are the values will come for the theta? So theta belongs to 0 to 2 pi means we can write theta belongs to 0 to 2 pi. The elements included in this condition is what? 1 by root 2 means pi by 4, 45 degrees. Then next angle, if you are taking, these values are pi by 4 will come, then next angle will be 3 pi by 4 will come, 3 pi by 4 will come, then we will have 5 pi by 4 will come, and we are having 7 pi by 4 also will come. So if you are taking the value of sine theta plus or minus 1 by root 2 in the given interval 0 to 2 pi, the values of thetas are pi by 4, 3 pi by 4, 5 pi by 4 as well as 7 pi by 4. Now question what we are having? Question we are having the sum of the elements in the particular given set A. So sum of the elements means that's it. We have to find the sum of all these things. So what will be the sum of all these things? What we are getting? Pi by 4 plus 3 pi by 4, pi by 4 plus 3 pi by 4 plus 5 pi by 4 plus 7 pi by 4. That will be equal to, yeah, denominator is 4 and numerator what we are having 7 plus 5, 12, 12 plus 3, 15 plus 1. 16 pi by 4, that will be equal to 4 pi, that's it. So sum of the elements in the given set will be 4 pi. That's all about the first question. It's as simple as that. You have to know the basic. Okay, you have to know the basic how to write a given complex number is in the form of a plus ib. As you know, the process is nothing but you have to multiply numerator and denominator with conjugate of the denominator, then you apply the condition. Here it is given the real part is 0, that means purely imaginary is given. Sometimes if they are given it's purely real, means what we can write, imaginary part will be equal to 0, that's fine. Okay, I hope this question is clear to everyone. So let's go to the next question. Okay, yeah, So Z be a complex number, Z be a complex number such that, so Z be a complex number such that magnitude of or modulus of Z minus 2i divided by Z plus I equal to 2. The given condition we are having Z not equal to minus I. Then Z lies on a circle of radius 2 and center. Okay, this question we can solve by multiple ways. This kind of question is latest trending type of question. Okay, so this kind of question we can solve by using the properties of complex numbers, and if someone don't know anything about the complex number properties, they also can easily solve by analyzing the given condition. Okay, so let me explain how to solve this question in a very efficient manner. So they are given Z is a complex number, right? I am explaining the easiest method that someone who don't know anything about the properties of complex numbers, okay, properties of Z, so how they will solve. So Z is a complex number, right? So if Z is a complex number, I can write Z will be equal to what? X plus Iy or A plus Ib. So let me take Z equal to X plus Iy. Okay. So it is a complex number given that some condition is given. What is the condition is given? The condition is given that modulus of Z minus 2i divided by Z plus I, that will be equal to 2. Okay, so I am just plugging this thing here. So instead of Z, I am writing X plus Iy, right? Because I started with X plus Iy. So X plus Iy, alright, minus 2i divided by, instead of this Z again I can write X plus Iy plus extra one more I is there. That will be equal to what? That will be equal to 2. Okay. Now what is the, how to find modulus of a complex number? Modulus of a complex number, very simple concept I am explaining. If Z is equal to some X plus Iy, if Z equal to some X plus Iy, then magnitude of Z will be equal to nothing but X square plus Y square, right? X square plus Y square. This is called a modulus of a complex number. Okay, so here modulus of numerator is given. We have to find the modulus of numerator, we have to find the modulus of denominator. So we have to do separately all these things. Okay, because magnitude modulus of A by B, I can write modulus of A by modulus of B. Leave all that thing and just try to solve. Okay, and before that I am just going to simplify this expression. X plus Iy minus 2i. So thus I can write X plus I into y minus 2, right, divided by, here X plus I am taking common, real part and imaginary part I am separating. Okay, so X plus I into y minus 2 will come when I am taking I common from second and third term, and from denominator X plus I into, then it will become y plus 1, right? That will be equal to 2. That will be equal to 2. Now you have to find the modulus of the numerator and the modulus of the denominator. So if X plus Iy is a complex number, its modulus will be under root of X square plus Y square. So its modulus will be what? Under root of X square plus, here y minus 2 is the imaginary part, so it will become y minus 2 whole square, divided by root of, here we are having X square plus y plus 1 the whole square. That will be equal to 2. Alright. Now if you want to remove, basically we are solving the question, if root terms are there, we will square both sides in order to cancel the root terms. So same process here also, if we are repeating here, what will happen? If I am squaring, this root will become cancelled. So x square plus y minus 2 the whole square divided by x square plus y plus 1 the whole square, that will be equal to 2 will become 4. Now transpose and simplify the given algebraic expression. So x square plus y minus 2 the whole square, that will be equal to 4 times this term will come x square plus y plus 1 the whole square, x square plus y plus 1 the whole square. Now just expand the given thing. So what we are having here, x square plus y minus 2 whole square, a minus b whole square, if I am expanding, it will become y square minus 4y plus 4. That will be equal to 4 into, here we are having x square plus y plus 1 whole square, if I am expanding, it will become y square plus 2y plus 1, y square plus 2y plus 1. Alright, so x square plus y square minus 4y plus 4, that will be equal to 4 into x square plus y square plus 2y plus 1. That's fine. Now just expand this thing and try to simplify. So what we are having here, x square plus y square minus 4y plus 4, that will be equal to 4x square plus 4y square plus 4 to 8y plus 4. Okay, that 4 I can cancel from both sides. Alright, now this plus x square plus y square and minus 4y, if I am transposing this side, so here 4x square minus x square, 3x square, 4y square minus y square, it will become 3y square, 8y minus not plus, so it will become 12y, that will be equal to 0. You can cancel the complete equation with what we are having 3, so this will become x square plus y square plus 12 by 3, 4y, that will be equal to 0. But they are telling it's a circle. Yes, it's a standard equation of circle. Standard equation of circle you studied in conics basics, you studied. If an equation of the circle in the standard form is x minus h whole square plus y minus k whole square equal to r square. This is the standard equation of a circle. So standard equation of a circle we know x minus h whole square plus y minus k whole square equal to x minus h whole square plus y minus k whole square equal to r square, where h comma k is the center and the radius will be r. Radius will be r. Same process if you are repeating here, just I want to convert in the standard form of x minus h whole square plus y minus k whole square equal to r square. So how I will convert? So x term is this one only, so I can't do anything. So x square, same thing, x square, okay, and y square plus 4y, just I am doing for square completion in order to get in the standard form. Okay, so how I am square completion, you know, y square plus 4y I wrote, then plus 2 square, so it will become y plus 2 whole square, right? So this extra 2 square I can add on RHS as well. So x square I can write x square itself plus y square plus 4y plus 2 square I can write y plus 2 the whole square, that will be equal to 2 square, right? So this thing is nothing, x square I can write if you want in the standard form x minus 0 whole square plus y plus 2 whole square, if you want you can write what you know, y minus 2 the whole square, that will be equal to 2 square. Now if you are comparing with your standard equation of the circle, x minus h whole square plus y minus k the whole square, that will be equal to r square. That's fine, perfectly done. Okay, now if we are comparing h comma k center, h comma k center of this circle, h comma k, as I told, if a circle is in the form of x minus h whole square plus y minus k whole square equal to r square, then center h comma k will be, center will be h comma k. So if I am comparing this with standard equation minus, here also I wrote minus in order to getting in the standard form. So h will be equal to 0 and radius will be equal to what we are having radius here. Radius we are having x minus h whole square plus, sorry, y minus k whole square equal to r square, radius already given to, that's fine, it's worked, and k will be equal to h is 0 and k will be minus 2. Okay, and the radius already given in the question, as per this framing this condition also we are getting radius will be equal to 2. So center of the circle is 0 comma minus 2 and radius of the circle is 2. It's nothing but pure applying the condition and simplifying properly, that's all. Okay. So the question what they are asking, center of the circle they are given and radius is given, center they are asking. So radius it is 2 and center will be 0 comma minus 2 will be the center of this x minus 0 whole square plus y minus 2 the whole square equal to 2 square, that will be the standard equation of the circle what we are getting. Okay. So I hope the second question also clear to everyone. All question we are applying the basic concept. Okay, we are not discussing very complicated and very difficult topics. Simple topic, how to score good marks. Okay, that only our intention. Okay. So let's go for the next question. Yes, it's a very easy question. It's a very easy question. So the question is, let z equal to x plus iy be a non-zero complex number such that z square equal to I into modulus of z square, then z lies on. It's a JEE Mains 2020 question. Okay, same concept what I told, what we applied in the last question, same thing we can apply here as well. So here they given z equal to what we are having, z equal to x plus iy, they already given, no need to take also. Okay, z equal to x plus iy is a non-zero complex number such that z square equal to what we are having, z square equal to I times magnitude of z square. Fine. Okay, so z is a complex number, so z square means x plus iy whole square, right? So x plus iy the whole square, that will be equal to I into what is magnitude, sorry, what is modulus of complex number. Last question also we did the same. If z is x plus iy, if z is x plus iy, then modulus of z will be equal to root of x square plus y square, right? So modulus of z is root x square plus y square. They are asking modulus of z the whole square. So the square of this thing will become what? This root will become cancelled. So only we are having x square plus y square. Just substitute this thing here. So I into we are having x square plus y square. That's fine. So now just expand the LHS part what we are getting here. If I am expanding x square plus a square plus 2ab. So 2xyi plus b square. B square means iy the whole square. That will be equal to I into x square plus y square. That means x square plus 2xyi. Iy square means y square, I square value minus 1. So you are getting minus y square, that will be equal to I into x square plus y square. Alright, just simplify because we have to write the complex number in the form of a plus ib format, right? That's the only our final intention is what? We have to write the complex number in the form of a plus ib. So if I am writing in the real part first, x square minus y square, yes that's fine, it's real part, plus I into 2xyi, right? So I into 2xy, that will be equal to what we are having, I into x square plus y square. Okay, now we have to use the concept, we have to use the idea. If two complex numbers are equal, if z1 is a complex number, z2 is another complex number. Okay, let me write z1 equal to some a1 plus ib1. Okay, and z2 equal to a2 plus ib2. Suppose if I am telling these two complex numbers are equal, if z1 equal to z2, then I can write a1 will be, real part will be equal to each other and imaginary part also will be equal to each other. Okay, so if two complex numbers are equal, what does it mean? The corresponding real and imaginary part are equal to each other. That only we did here also. Okay. But here there is no need, right? Okay, last question there is no need. So this question you have to use the concept also. If two complex numbers are equal, real part will be equal to each other and imaginary part also will be equal to each other. So here what I can write here, you know, x square minus y square is real part. Okay, plus I into 2xy is imaginary part. That will be equal to here no real part. So you can put 0. So 0 plus I into x square plus y square. That's fine. Okay, so if two complex numbers are equal, what I told, real part is equal. So here you can write x square minus y square equal to 0. Okay, and this is the real part, x square minus y square. Here in RHS real part is 0. So that will be equal to each other. And here I can write 2xy, that will be equal to x square plus y square also. Okay, so then what's the question? Z is a complex number such that z square equal to I modulus of z the square, then z is lies on real axis, line y equal to x, line y equal to minus x and imaginary axis. That's fine. So just you can solve very easily, you can solve very easily as well as very smartly this question. You can take any one of the given. Okay, you can take any one of the given condition x square minus y square equal to 0, or you can write 2xy, you can take this one also. Suppose if I am taking x square minus y square equal to 0, x square minus y square equal to 0 means what? A square minus b square format. If a square minus b square equal to 0, a square minus b square, I can write what? A plus b into a minus b. So x plus y into x minus y equal to 0, right? So from here I can write x plus y equal to 0, x is equal to minus y, I can write x minus y equal to 0, I can write x is equal to y also. Okay, so x is equal to y minus x equal to y. So I can't predict because both options are coming. So let's check this imaginary part equating part also. So if imaginary part, if I am equating x square plus y square, 2xy I am transposing, so minus 2xy equal to 0. So x square plus y square minus 2xy equal to 0 means nothing but it is in the form of a minus b whole square. So I can write x minus y whole square is 0. X minus y whole square 0 means x minus y whole square 0 means what? If x minus y whole square equal to 0, what does it mean? This means x minus y also 0. That means x equal to y. Yes. So in both cases, if you are simplifying the real parts also, if you are simplifying the imaginary part also, equating and simplifying imaginary part also, if you are observing in both sides, you are getting x equal to y, x equal to y. That's all. So where this complex number is lying on the equation y equal to x or x equal to y. Easy question. Just simplify, that's all. Okay. So I hope this question is clear to everyone. We are only using the concept of magnitude, modulus of a complex number and equality of complex numbers. Okay. So I hope this question also clear to everyone. So I hope we discuss few important questions and same pattern one more question I am giving to you guys. Okay, this question exactly the copy of what we discussed in the second and third question. Okay, same pattern one question I am giving and first question is little bit different and this is the fourth question that you have to do by yourself and put all your effort, same concept, same idea. Z is a complex number such that same magnitude condition is given and the magnitude of Z also given, it's 5 by 2. Value of Z plus 3i, magnitude of Z plus 3i they are asking. So you have to solve this question by your own, by carefully watching this video and understanding all the concept what we discussed. Then after that you have to put your answer, it's an integer or fraction, something will come. So you can put your answer in comment section. Okay. So I will verify the answers and if you are having any doubts you can ask the same in the comment section through it. Okay. So thank you for watching Unique World Education UAE YouTube classes. So that's all about today.